There's an issue with pianos that's puzzled pianists and technicians alike for many, many years. Why is it that two apparently identical pianos, same make, same size, same age, will play completely differently? One of them may be light and responsive and easy to play, and the one next to it is like driving a truck. It's really heavy and tiring. One of them you may be able to play right down to the quietest pianissimo, and the one next to it you can only play loud because it's so heavy. Equally, as a technician, why could we never be 100% certain when you were replacing hammers or rebuilding the action exactly how the job was going to turn out? This is a story about an idea and a process that goes a long way to answering those questions. My name's Steve Carroll-Turner. I'm a piano technician. I've been working with pianos, tuning and rebuilding and restoring and servicing for the better part of 30 years. Back in the 1990s, I worked for Bosendorfer pianos in London, doing concerts and recording work before we moved down here to Brighton, where I set up my own business. And over the last 7 or 8 years, I've started to specialise in the redesign and rebuilding of grand piano actions using a process called precision touch design. This is Finchcock's in Kent, for many years a famous museum of historical keyboard instruments. It's now used for residential piano courses. I'm at Finchcock's to pick up the action of their Bosendorfer Model 200 6'7" piano, which is one of their main performance pianos here for the courses. The action's very worn, so I'm going to be replacing all the worn felts and also fitting new hammers and new shanks, complete rebuild. And because of the curiosity and persistence of a brilliant American piano technician, engineer and inventor called David Stanwood, I can be absolutely certain of how it's going to turn out and the quality of the end product. The piano action is basically a seesaw. You push one end of the seesaw down, it pivots over the pivot point, and it lifts the repetition lever and the hammer at the other end of the seesaw. And like a seesaw, its movement depends on how heavy the weight at each end is and how far away from the pivot point these weights are. When designing a piano action, the traditional approach was to first work out the position of the pivot point of the key and then balance whatever the weight of the hammer was by using lead weights in the front of the key. But David Stanwood, after many years of research and the analysis of hundreds of piano actions, turned that approach on its head. If you start with the hammer, you can achieve perfect leverage by calculating exactly where the pivot point needs to be for that weight of hammer. This is the great American jazz pianist Keith Jarrett playing one of my all-time favourite tunes, Someone to Watch Over Me. It's off an album of Jarrett's called The Melody at Night with You. Back in the 90s, Jarrett suffered really, really badly with chronic fatigue syndrome to the point where he couldn't even play. So he enlisted David Stanwood's help, and the action of Jarrett's Steinway Model C in his home studio was recalibrated using precision touch design with particular attention to what we call the balance weight, which is the relationship between the down weight and the up weight. That recalibration enabled Jarrett to be able to play again and inspired him to make this album. And he said himself that nothing he's recorded is more important to him, and he made it as a gift for his wife. This story also speaks to a crucial benefit of precision touch design. Having his action rebalanced enables Jarrett to play again and to record, but will also protect any pianist against tendinitis and other RSI type problems. The action can be designed to be lighter or heavier, but because the leverage is always perfect, the action will work with you rather than against you. After all of Stanwood's work in the States, the next chapter of the story moves to Holland. Two Dutch technicians, Wim Veldhuis and Frans Pietjo, enlisted Stanwood's help in a couple of projects that they were involved in. And this contact led to two important things. Firstly, Wim and Frans set up the PTDAE, the Precision Touch Design Academy Europe, to run training courses to teach technicians in the Stanwood protocols. And they developed software which would enable the process to be done by anyone with basic computer skills. I first met Wim and Frans at a PTA convention in 2013, and shortly after that I went over to Holland and did one of their 5-day training courses. And since then I've used Precision Touch Design in about 30 or so pianos, including all of the top piano makes: Steinway, Bösendorfer, Bechstein, Bluthner, Yamaha, Kawai and many others.
I'm the owner of this glorious Bösendorfer and have been for about 35 years now. I had it from new. We had a lot of work done to it last year, and it is now, I think, in condition that is better than when it was new in so many ways. It's really been extremely surprising, actually. Steve had mentioned to me a few years ago that he was interested in this quite new, quite innovative way of rebuilding pianos. And then the obvious time to do that was during this rehammering. And so we went for it, and it has been extraordinary. It really is. And now to play a Bach fugue and the evenness of the polyphony, what I can actually do with my fingers, is quite surprising. I really thought I was rather ham-fisted at these things for many, many years. And now it turns out that what I needed was this precision touch. It really does make a difference that you can balance one note to another note. You can balance a 4-part fugue with such a level of subtlety and such control that it has simply made me a better pianist.
So, how do you do it? You take a sample of notes from across the keyboard, all the C's and C sharps, and you weigh all the component parts of each note: the hammer, the wippen, the front weight of the key, and you measure what we refer to as the up weight and the down weight. You enter all of these values for each of the 18 notes into the design chart in the software, and this is what you see. This graph shows the hammer weights. I've actually entered all 88 hammer notes in this, and you can see the variations in weight between individual hammers and also much too much weight in the hammers in the top treble. This graph is the really clever one. The red line gives you the values for the optimum position of the pivot point for that weight of hammer. Once you've achieved that and matched the blue line to it, this graph gives you the values for the exact weight that there should be in the front of each key.
I started learning the piano when I was 4, and I learnt from this really lovely warm woman called Myrtle Katz. After she died, we found out that she left this piano to me in her will. The sound was getting very hard and it felt just very restricted. And so I realised I'd have to have some work done on it, and that's when I got in touch with you, Steve. And immediately, yeah, it was a really big difference, because the sound, well, it was much more soft-grained, really. I don't know why, just the minute I played it, it said, I thought that was its real voice. It had a sort of a real character. It wasn't quirky or anything, it just had a centre to the sound and a bloom. And it wasn't anonymous, it wasn't quirky or anonymous, it had its true voice, and I thought, yes, that's the one. And I was so happy. It was just lovely. I'm blushing. Great moment. Steve's blushing.
There's a reason this process is called precision touch design. We've done the design. The precision bit involves actually setting those weights to a level of accuracy that didn't even occur to traditional action makers. The weight of each key is set to an accuracy of plus or minus 0.3 grams. And the weight of each hammer is set by filing the wood or adding tiny lead weights to a tolerance of plus or minus 0.1 grams.
So that responds very nicely there to the change of dynamic.
Glorious.
solo parts.
That's just gorgeous.
And there was something here. About the control I feel between the, the bringing out that's singing beautifully, isn't it? That note, and then just
the rippling stream underneath.
It's literally a stream, isn't it? That feels really easy.
That's a great demonstration of it, actually, the way you can sing the top line and just ripple underneath.
That's just working like a dream.
I'm on my way back to Finchclocks now with the redesigned, rebuilt Action. I've still got a fair bit to do, regulation, setting up, all the refined toning and voicing, but we're nearly there.